You missed a spot.
Mhm.
Yeah, yeah.
More questions?
I was trying to see if there.
I have,
Oh, I guess that's the only question on.
I have a thought question. Probably I'm the eldest one here. I'm the eldest one, 30 years working on forest fire, and I was always claiming that we need more socioeconomics because at the beginning the research on forest fire was very biophysical. You know, plants. The ecologists were the first ones that pay attention to forest fires. And now I think we need also the scientists to think about the chance that the fire will be present. You know, most of our projects is how to remove the fire, how that the fire will not exist. And I think it's a mistake. We need to live with fire.
That's an
How
interesting.
is the key question?
Yeah.
How is the key question? But just try to find alternatives, like grazing or thinning or prevention and so on. At the end, it's just going against nature because fire is better. This is a thought.
It's very interesting that you say that because I'm actually from the US and the relationship with fire in the US. I used to work for the US Forest Service for a few years, and the relationship with fire is much different than the relationship with fire in Europe. And it's been interesting to see this. In the US, after the Dust Bowl in our history, Smokey Bear, you know, we had to recognize that if you don't burn or you don't manage, then you just get bigger fires. And even if you do manage, you still get what happens in the US. But I think in Europe, that's like a newer paradigm that's coming in that you do, yeah, we have to find a way to kind of live with these fuels and manage them and not just.
I did some socioeconomic research also.
Right.
And especially I'm interested in the perception of the people. I didn't publish, but I have very interesting results in a study area which is called Macizo del Carrocha in Valencia. And then I did interviews of people, almost 100 interviews. And then the people that was older than 75, all of them accept that fire should be present.
Right.
But all the people younger than 25, the reply is, no, forest fire should not exist. We need to eliminate.
Right.
You know, and this is a big problem.
Yeah,
because
totally.
the people that is right is the old one, and they will go in a few years' time. Meanwhile, the young people who is studying at the university, that will be the next teachers, they are wrong, completely wrong.
Yeah.
Okay.
And then we as a scientists, we need to transfer this
I
to the
think that
society.
this depends on the origin of the fire, because in Portugal, the problem is the eucalyptus.
Yeah.
We have all the territory occupied by eucalyptus.
Yeah.
And it's different. I don't agree with you. When I think in Portugal, not in the other ecosystems.
You have the eucalyptus because it's a plantation.
No. The problem is, of course, that we have plantations, but of course that now we have eucalyptus everywhere, occupying all the areas, and they are not being managed outside the plantations. So that's the problem. This is why we have big wildfire.
We have Aleppo pine.
Sorry?
We have Aleppo pine. That is like a eucalyptus. It's not from Australia. It's native from the Mediterranean. But still, we have spread a huge amount of Aleppo pine in the area.
I would like to comment that fire risk aims to address the negative effects of extreme wildfires. So under the current conditions of climate change and those fires which are currently exceeding the response capacity of firefighters and civil protection services, we need to address those negative effects. And we had a meeting recently in Coimbra. We had an excursion around the area to see the local communities, how they tackle in some areas with eucalyptus really next to their fences, and even to very close to the walls of the houses. So, well, they told us and let us know how they managed to engage with the local government and to see how they could start to clean all that area and to see how that could be at least change. One of the possibilities could be to introduce other species, but obviously when you talk to biologists and ecologists, that often another box, another discussion, and it's difficult to find a trade-off for everyone. But it seems that since there are certain paper companies, pulp and paper companies, and they are trying as well to, or they tend to plant other species and to see how they can make profit out of other species apart from eucalyptus. But it's not to get rid of fire or to take it. I started saying that wildfire can either mediate or endanger ecological processes. It depends, obviously, depending on the tree species that you have. You need fire to for your growing cycle. So we acknowledge that, but we are tending to address the most negative effects of extreme wildfire.
Also, something like land abandonment, which is where I started it, that's a different, you know, that's where probably there was someone like a 75-year-old who used to manage that farm and doesn't anymore, and so.
And at the moment, we are looking at this project in a kind of integrated way. It was one of the things, but because of the pitch was really short, I didn't mention it. Related to the water management, that they were considering to look into the past, current, and future. Well, in this integrated strategy, we are looking at everything. We are learning from past, looking at current situation, and analyzing the future projections and scenarios. For land use as well, for land use, land management, socioeconomic, and climate.
One of the things that we came back always is here is to Portugal. And Galicia in Spain also is a lot of forest fires. And this is a socioeconomic issue. Because Galicia or north of Portugal are much better than the Mediterranean where I live. It should be more forest fires. Now it's prone to burn everything. But there is one thing that we always are talking about land abandonment, that she was telling, or eucalyptus. But there are big changes. For example, abandonment means that you recover a forest in the middle of the abandoned land. But there is another forest that is growing, and it's in the urbanization. In the Mediterranean, we are growing a lot of Aleppo pine where the houses are, where the people is living. And this is a time bomb. We can say that this is a fire time bomb. We are preparing a big fire with a lot of dead people, because it's where people is living. And you will see in the Mediterranean, in Alicante, in Valencia, but also in Madrid or in Soria urbanization, that the people planted trees, especially pines, and they are close to the houses. And this is, the Greeks already have a lot of experience on that. I remember that in one forest fire, there was 100 dead people.
In Attica, it's one of the largest ones.
And the people die without being touched by the fire, only because the heat, and they breathe air that was so high temperature, and they die because of that. You don't need to be burned to die because of forest fire. We are preparing the situation because we are not aware of the risk. Then you need to solve with your project everything.
Well, not everything, but at least one of the questions that you mentioned is the target audiences. So we have from scientists to landowners, different communities from governance. We are trying to address as well NGOs, civil protection, and firefighters. Firefighters is a large community within the project. So the survey that Alex showed is related to a very limited and committee of experts to give feedback and to run some models related to the management strategies and socioeconomic analysis. But we have another one to gather end user needs, which would be obviously those communities which are providing us with different expertise and knowledge from different places. So what we see at the moment is that the policy that we have, apart from the regionalized, considering different countries, is more focused on suppression rather than prevention, and we are trying to see that paradigm.
Even our government is more concerned with suppression rather than prevention.
Yes.
That's the main problem. The problem starts there.
So that's the main aim of the project, trying to. So the paradigm shift is moving towards that, changing the suppression approach towards the prevention.
Okay, we go for the next speaker, which is you, Ruth, no? Yeah, we are going to go first with the two first people that is here, and then the other four will be can be chaotic. Let's see. Well, it's native soil microalgae and cyanobacteria consortium as a natural-based solution for the immediate protection of palm soils. By
Here.
Ruth Pereira. Wow, Ruth Pereira and many people, no?
Yeah,
Yeah.
it's all the research team involved in the whole project as well. So I will present you this topic, a project where we are using native soil microalgae and cyanobacteria to remediate burnt soils and to prevent erosion and to promote fertility to recover the overall community. So we were discussing about this. Forest fires are rural fires are being a great problem in Portugal as well as in all the Mediterranean region. I think that the worst year that we had, it was in 2017, because not only based on these numbers, because it was the year where we don't have so many occurrences like in 2003, where we have a great heat wave. But the area that was burned was bigger, and even worse, it was very dramatic because we have many people died due to the fires. So based on this, our Foundation for Science and Technology decided to open a specific call related with the prevention and also with the remediation of forest fires. And we apply it with the two projects, but I'm talking here with about one of them, which was the Green Rehab project, whose the main objective was to develop a rehabilitation system for these burned soils based on the native soil microalgae and cyanobacteria. So, as we also have been discussing, we have to work with the municipalities, firefighters, and with the populations, and we decided to work with this municipality in the center of the country, which is called Mortágua municipality. You see here the map of the area, and it's apparently it's very nice because it has all the soil uses is mainly dedicated to forestry, but 80%, 86% of these forestry are eucalyptus. Of course, because this is a municipality that is producing as many eucalyptus plantation. They are producing eucalyptus for the production of paper, but also in many areas now they don't have plantations and they are occupied by eucalyptus anyway. And so we decided to work with them, and we are doing this. The project is ongoing. The first thing that we did, we went there, so we collect soil crusts from different sites. We isolated different cyanobacteria and microalgae from these soil crusts, and which were purified, were characterized based in a polyphasic approach. So we make a morphological characterization. Also, to characterize the ultrastructural characteristics, we used electronic microscope. We sequencing molecular markers to make also a phylogenetic analysis. And now we have a great collection of species that we collected from this area. Afterwards, what was needed? We need to test which was the best culture medium from liquid mediums, especially this type of medium, which is rich in nitrogen, nitrates. And also we need to think which type of solids material we can use to culture some of the species because it's normal. They are from the soil, so they are used to grow in solid surfaces. And so some of them need solid support to grow. So everything, all of this was tested. And at the end, this is the work that I'm going to describe here. At the end, we need to start testing consortiums of these species to apply to the soils and to see first if this species, this is the objective of the work that I'm going to present. We need to realize if these organisms will survive in a burnt soil, because after a forest fire, we also have contaminants on this soil, namely polycyclic aromatic hydrocarbons that can be highly toxic. And so we need to know if the consortium can survive on the burnt soil, and if they can grow, and also if they can contribute to improve soil physical and chemical properties, and also some biochemical properties that I will show. So, but the curious thing, and it's good, okay, but it's good for all of us, but not good for the project, is that we don't have fires on this region, fortunately, since the project started. So what we did, we collect soils from there, and we went to the University of Coimbra, that is another university in the central part of the country that you know very well.
So the names.
Yeah, you know them. And they have a forest fire research laboratory where they study the behavior of the fire. So they have simulators. So we went there with our soil, and we simulate a fire, and we brought the burnt soil to then to test in the lab. So, but the fire that we were able to get in this laboratory was characterized as a low intensity fire, which the maximum temperature was attained was 64 degrees on the soil, but the air temperature attained more than 800 degrees. After that, we brought the burnt soil to the laboratory, and we have our consortium of already decided which organisms we are going to join. So mainly cyanobacteria, but also algae that were tested previously isolated. I only will show you the results of the combination of all of these species. And we have this treatment in the laboratory. So a control that was only irrigated with water, two other controls that received the growth medium of the organisms, and the perlite, which was the solid substrate that was used to grow some cyanobacteria. And here we have the treatment of the all of this is burnt soil, and here we have the treatments with the inoculum of the consortium, both added with the perlite and the Bigellus medium, and only with the Bigellus medium to see if they grow or not, because it was better if you don't need perlite for the inoculation. This experiment took 90 days. After this, the addition of the inoculum, we only irrigate treatments with water. We don't use no nutrients and nothing more. And the treatments were kept at this constant temperature and photo period. And afterwards, we analyzed these parameters: soil physical and chemical parameters, soil microbial activity, chlorophyll A content, at the end of the experiment. But during the experiment, we manage and we use these V's-Near portable spectrometer. It measures spectral reflectance in the region of visible and near infrared light, and we use this device to monitor the reflectance of the surface soil to realize if the consortium was developing or not. So these are our results, and these are for physical and chemical properties after we have burned the soil in the University of Coimbra, so nothing new. These results are being reported by many other studies when they describe what happens to our soil properties when there fire occurs. So there was a slight increase in pH, which is being attributed to the addition of ashes to the soil, ashes that result from the burnt vegetation, which has usually are rich in alkali compounds. Also, we have an increase in aggregate stability that is more common in less intense fires than in more intense fires. Also, we have an increase in the water hydrophobicity of soil to water. So the time needed to water penetrate in the soil increase. And regarding the other, the organic matter didn't change, the water holding capacity low, but the electrical conductivity also increased, which also is normal because there are several inorganic ions that are being released, so they increase the electrical conductivity. And regarding the aggregate stability, when the fire is not too much intense, some hydrophobic compounds can contribute to stabilize aggregates as they can accumulate in soil aggregates. And so this is a possible explanation for these results. But when we brought the soil and when we start the experiment that I described it with the different treatments, after 90 days, we didn't find great modifications in soil properties. So the inoculation of the soils with the microorganisms did not change the soil properties significantly after this period. When we get to the biochemical parameters to evaluate if the soil microbial community is recovering or not, we found that we have some differences and the responses are sometimes complex, and we have some differences in the treatments where we had the inoculant, but sometimes are not consistent depending if we add perlite or if we only add liquid medium. But at least in this treatment we have the increase of dehydrogenase activity, which is an enzyme that shows us that the metabolic activity of the soil microbial community is being promoted. And we also have an increase in both treatments with the microorganisms of the phosphatase, acid phosphatase enzymes that are enzymes involved in the phosphorus cycles. And usually these enzymes are activated when the phosphorus is not available. And we also heard that fires increase the availability of nutrients, but it's true that fires also increase the mobility of nutrients. And probably they were available, but they were moved with irrigation from the system, and or at least they can also be complexed and being less available. And this is the reason why these enzymes the activity was increased. Regarding the enzymes involved in the nitrogen cycle, of course, that if we have here changes, we can imagine that they can be caused by the medium that we had, because the medium that we had, the Big Ewoons medium, is rich in nitrates. So if we had nitrates, probably we can affecting this potential nitrification, probably inhibiting. But it was only had in the beginning. And what we see here is the promotion of the activity of the enzymes that are involved in the degradation of nitrogen compounds in the soil to get ammonia free to be used. So our hypothesis of, okay, the nitrogen cycle is being affected, positively in these treatments, and what this demonstrates is probably the soil microbial community is requesting nitrogen, is needing nitrogen, and the heterocyst forming cyanobacteria that we add to the system, they are able to fix nitrogen from the atmosphere, but probably they are not able to fix all the nitrogen that is needed for the soil microbial community that is evolving. And regarding the development of the consortium, this is the most interesting part, is that, okay, we follow through different weeks, measuring the total chlorophyll content of the soil, and we realized that it was the inoculum was viable and developed in the soil, and so first it starts better in the perlite treatment, but afterward, at the end, we have a great development in the treatments where it was inoculated with only with liquid medium. What is positive, and I will tell you why. And regarding the spectral measurements, they were coincident with the ones that we made with chlorophyll A, because these two treatments that we see here growing are once again the treatments where the inoculum were applied. And what we measured here are the normalized difference vegetation index, which is based on, in this case, it was based on near infrared reflectance of the surface of the soil, and this reflection was used as a photosynthetic activity index because it can be correlated with the pigments of the cells of the microorganisms, because they don't absorb light on these wavelengths and they reflect all the light. So this is a good indicator of the presence of these pigments in the soil. And now, just to conclude, the positive thing is, okay, we see that we have the consortium was able to tolerate burn soil. At least we don't know if all the species still there, but what we are doing now, we are concluding a meter barcoding analysis of the soil collected from the different treatments to be sure that at the end of the 90 days we have precisely there the same species that we have added in the beginning. We didn't record changes on the soil properties, main soil physical and chemical properties. 90 days probably are not enough, and the other problem is that we are testing mainly the first centimeters of soil, because it's where these microorganisms establish, and this probably has limited to find such difference in physical and chemical properties. The other positive thing is that we know that soil enzyme activity is highly affected after a fire, because the fire causes the denaturation of the enzymes, of the pool of the enzymes of the soils. And the positive thing is that we are recording a recovery of this enzymatic activity, mainly of the enzymes that are involved in two important biogeochemical cycles, which is the nitrogen and phosphorus cycle. What we are going to do now, once again, we still have no fires in Mortágua, what is good. So we collaborate with the municipality, we collaborate with the firefighters, and also with the organization that is called the Civil Protection. And it was made a controlled fire in the place. And now we go to the field and we are going to apply. We have several months to grow the great volumes of these bacteria. And we are going to apply now the consortium in the field and to monitor Once again, soil physical and chemical properties, biochemical, biodiversity as well, and the re-establishment of the vegetation community will also be monitored through spectral imaging using remote sensing using drones. And one of our objectives, working with people that lives close to these places, that work on these plantations, that have the owners, and one of the objectives is also to work with them and try to see if we are going to be able to culture this consortium in local facilities, because the idea was, okay, we have a fire, if this material is close to people, they can irrigate the soil immediately with this type of consortium to try to reduce erosion, try to recover the soil as fast as possible. So, and is the last one. Thank you very much for your attention. You helped me to end. Thank you.
Okay. Do you have any questions for Ruth?
Sorry, but I was checking there are some questions on the chat, but they're from before, no?
Oh,
There is still someone problems to see the slide.
Problems with, okay.
Yeah, we did not see this. Okay. I don't know.
I have a question, only a small question. From the practical point of view, what do you expect?
It's because you need to change to another data people will see. And I thought you already changed it.
There is specificity between the different cyanobacteria and the species they grow.
Yes, the species, we try to grow as much as possible and to isolate as much as possible that we found on the area. And that were culturable in the laboratory. Usually it's a small proportion of them. But then we select the species based on their properties, on their functions on the soil. So, and we mix them, and the question was, because the other problems is, okay, we are culturing them, and in the soil they live together and they are in their conditions, but now let's see if they grow together as well in the laboratory. This was another challenge, and we try to grow this consortium in the laboratory, and they grow well. And now is to apply in the field is the next step. And the positive thing is that they don't need trolleys.
Yes.
Now they are growing well, which makes things easier because now you can spread easily. So the next step, and it's probably a little bit realistic, but let's see, is that in lots of these villages you have small tanks and facilities, but probably we can try to grow and people can have this material available and to spread if they have or we can do it because we have a company involved as well. So some companies can be specialized in keeping this consortium and in delivering it when it needs, because the idea is to apply as soon as possible after a fire.
In combination with other measures to avoid the erosion control, no?
Yes.
Avoid the loss of the.
Yes. Because
for me, it's
because they form crusts in the soil. So if they form crusts, the soil becomes heavier, so it's not so easy to be eroded.
Okay, we go for the next speaker. I'm not sure if everybody's listening to me. The next speaker is Sergei Sidorenko, and he will be online. Do you hear me, Sergei?
Good day, everyone.
Now,
yes, I hear you, but I have.
I can hear you now.
Oh, okay. So, good evening, everyone. Are you hear me?
Go ahead, please.
Okay, so I will control my presentation, or you will assist me.
Yes, we need to see his presentation.
Basically, I can try. I think I have a permission for it, so just a moment.
You need to show. You need to show your presentation. If you don't show, we cannot see.
Okay. Can you see it?
No.
Just a moment. Let's try again.
We need another pandemic to adapt to this.
And now you see my presentation on the screen. Because I share a screen now.
When you will share, we will not see you, and we will see the presentation. And now we are watching you.
Just a moment. Maybe you can assist me with the presentation, and I will just focus on.
But different. I don't have your presentation.
I have it. I was trying to.
Okay, somebody else is having. Okay.
Because I share a screen, but you can see it.
Do I have to copy the one?
I think that's me. Is that not mine?
I think that we have to send it. Now you can. Maybe close the
This one's
Close the other ones. That's right.
Yes, close it. This is this one. Okay. The right one.
supposed to be another screen here.
Here's one, I think. Can you see it? Can you hear me?
Can you put in big, Emily?
Yeah.
That's it.
So can you see it? This is something, but I'm not sure if the. But no one sees anything.
Maybe I should try again to share it.
No, it's not in the comment.
We need to click on it. I'll send that. I'm supposed to work.
Can you see it?
Oh yeah, yes. I'm seeing it, but I have some issue with the screen. Oh yes, yep.
No,
My
slides.
Yeah.
Okay, now
Microsoft.
now you talk, and we will pass the slides. Okay, we just follow.
Okay.
Go ahead, Sergey.
Okay, let's try. So good day, everyone. Incredibly happy to be here today. I am Sergey Sidorenko. Unfortunately, our main author is unavailable, so I will be a presenter today. Nowadays in Ukraine, it's very hard to plan something because of war. So, basically, our presentation is about the approach for selection of fire risk assessment, reduction and adaptation products for demonstration within Fire Risk project. Please, can you change slide? Basically, this slide we can skip because, as I know, we have these amazing posters from Fire EURISC. So I don't want to take some extra time, so we will skip this one. And many research projects, especially in Ukraine, have an issue when developed by scientists products can be used primarily by scientists, which are quite hard to use by practitioners. And our philosophy here is that science should work for those who are really involved in the fire management and will use those products directly. So we need to keep an eye on real user needs. And this project aims to take into account real needs of end users. And then user needs were collected through questionnaires, and then needs that gathered were translated into requirements for products. Please change slide.
Sergey, I think something happening with you.
Yes, I have some technical issues with Microsoft Teams. It's like some delays. So under the umbrella of Fire EURISC, 24 partners from research institutions, companies, NGOs, and other services work on creation of products to support wildfire management. And currently 59 products was developed. And those products cover the range from fire modeling and fire behavior to fire danger, fire ecology, as well as fire policy to support risk assessment. This will have to reach main wildfire management objectives. The technological components and the methods that are developed in the project will be firstly tested and evaluated jointly with local stakeholders in the 26 demonstration areas within the European Union, and one demonstration area in Great Britain, and one in Ukraine in Chernobyl exclusion zone. After that, then the projects will demonstrate the scalability of these projects and its solutions, applying the result to larger areas to a pilot size and the whole European territory. Please change slide. Okay, thank you. And here you see distribution of products by their coverage. Basically, a list of products was updated recently. And here we see that even in that stage of a project, basically it is the second year of a project, 7 products have European coverage and will be tested for whole European territory. And 13 of them will be tested for pilot size for like a regional scale. Also, we have products without clear coverage, but it is this project connected to guidelines, some knowledge database, and some specific software that basically don't have coverage. Please change slide. Okay. Here we see the distribution of products by the. We lost one slide here. Please, can you just skip one again? Okay. One slide. Next. Yes, we lost one. So selection of products for European level is like one key goals of that project, and presently we are considering that the concept of future European architecture of data sets, apps, and web platform for fire policy, science, and management must be based on evaluation inside the following groups of products, like a fire behavior, fire danger rating, fire effects, fire risk, firefighter safety, force management, monitoring, reference and guides, and software group. Please, one slide next. As I mentioned before, the main disadvantage of research projects, some research projects, is that developed by scientists products can be used primarily by scientists, and for example created guidelines which are quite hard to use by target audience, or some specific software or geoportals that are very hard to use by practitioners. So we stand for approaches when science should work for those audience who are really involved in the usage. As I mentioned before, this project aims to take into account real needs of end users, and even a preliminary and a glance analysis of list of products may give us like a conclusion that most of the products is designed for a couple targeting groups. So here we have products not only for scientific community, but also a whole bunch of products for landowners, for first responders, and even for general public. Please, next slide. Please, next slide. Oh, I have some problems with connection.
It's already passed. Now you see a problem.
I'm sorry, I still see slide number 9.
Yeah, it's number 9 now.
Can you switch to next slide? Oh, thank you. So we found that a clear, structured, and rational approach for fire management product selection is absent in the literature. Due to this, it is important to fill this gap by developing a specific product selection methodology. Due to this, please, can you switch to next slide? And next one, this we will. Please, next slide. Due to this, the main criteria that is leading the selection within a project are user requirements, scalability, and availability of a products. Is coverage for pan-European territory. Each of those products uses their own methodology, architecture, as well as specific input data and limitations connected with the usage. Also, products provided performing different fire components due to integration strategy, and belonging to ignition probability, propagation, exposure, and vulnerability. To release this scheme, we are considering the future development of the methodology with the users of the adaptation of several methodology, like quality function deployment, multi-criteria decision-making techniques, and analytic hierarchy process. This approach will help us consider both end users' needs and product selection criteria to build a hybrid decision-making solution. Please, next slide. Despite the fact that this is actually just the second year of the project, it is worth to notice the significant progress made so far. by a project team. In a relatively short period, 59 products have been developed, some of which claim to be upscaling to the European level. For the first time, a fuel map for the entire European territory was created, and there are other bright examples of successful products. Despite all those successes, we expect even more active involvement in the evaluation and testing of scientific products by practitioners who will eventually use those products. Also, we are still waiting for end user requirements that we can see and get on the mid of August. And then we will finalize our methodology for product selection. So thank you all for time and attention, and sorry for these technical issues. It's not easy to do it online, and I'm sorry for it.
Thank you, Sergio. And, do you have any questions? Okay.
I don't know if our colleague
Which, yeah, go ahead with the question. I think he's hearing us.
So please, first of all, I would like to wish you that these dark moments of our history end as soon as possible. And I'm curious about your site in Ukraine, in the Chernobyl exclusion zone. Because this is a complex problem. I understand your concerns with fires there, but you are taking also into account the interaction between fire, contamination, and this will be done, or?
Thank you for your question. Yes, really, a demonstration area in Ukraine is connected primarily for Chernobyl exclusion zone, and two products will be developed due to the project schedule. One is connected to fire danger assessment, and one about Cron-based hate. Also, we proposed to tested in this area like a cascading effect. In fact, it is that about what you're saying. So to analyze interactions between wildfires, bark beetle attacks, and also smoke exposure with radionuclide. So all the thing is interacted, and yeah, we of course we think about it, and I think we will finish it in terms. So thank you.
Okay, thank you very much. So we go for the next speaker, which is also online. Is Mario. Mario, are you ready?
Yes. Hello.
Okay, Mario, go ahead. We don't have your presentation, then you need to know how to put it in online.
We already sent it this morning, but do you want me to share my screen? Is that feasible?
But you sent this morning to who?
Yanis.
Okay. But Yanis didn't send to us.
Yeah, we sent it to Yanis. And also to before it to Gil, someone named Gil. Would you like me to share my screen? Would it be?
Yeah, please share your screen.
It'd be easier, maybe.
Because you need to send to the chair of the session. Me or to Marta.
Yeah, we will initially.
Not at the end, there's too many people in the middle, and he's not right. Okay.
Yeah. Initially, we were coming to Utrecht, but we had one COVID case, and one bad travel
No
case.
problem, no problem. Go ahead, we need to solve now the situation, okay?
Yes, can you see my presentation?
This one, yeah.
Yes.
Yes.
Okay, so is my screen visible to everyone?
Yeah, go ahead.
Okay.
To make it
So, I will be introducing the work we did in Resilience on forest fire. We are a consulting design modeling and business strategy company. We are based in Paris. We work on consulting, modeling, and project coordination on various disciplines. Can you see me changing my slides?
Yeah.
Okay, so including several ecosystems, including the urban ecosystem, natural ecosystems, and others. We have a large network of partners. We work namely on remote sensing and digitalization with several partners. These are to list a few. We have 76 projects around the world, but more than 55 countries are implicated. This time I will be presenting the modeling of forest fire. Excuse me? Excuse me, yes?
Go ahead, go ahead.
This time I will be presenting the modeling of forest fire risks in southern Corsica and France, and how we developed a decision support tool for local authorities and land managers. So, as we know, fires are increasingly threatening Mediterranean ecosystems. Yearly 6,000 fires ravage around 500,000 to 800,000 hectares per year. As climate change is progressing, the intensity, the frequency, and the severity of these fires is only expected to increase proportionally. With the expansion of wildlife-urban interface, we are putting more urban cover at contact with natural flammable cover. This simple representation is also the case of electrical infrastructure, where we see that often electrical infrastructure is also extending into wide areas. In the case of southern Corsica, which belongs to southern France, it's one of the country's most flammable areas, if we may say. A series of high linear voltage electric poles is planned between Porto Vecchio and Bonifacio. It's actually undergoing and it's expected to extend further. However, the project is faced by large public inacceptance because for people, the area is already under high risk of fire and we don't need electrical currents to intensify flammability risk. So public acceptance is really a problem in this facing this project. Therefore, we interfered to create a tool for monitoring and analyzing these forest fires by identifying different fire hazard zones and providing insights on the positions of the pylons with different hazards. To extend beyond a simple characterization of hazards, we wanted to use the height of the pylons as a leverage to put thermal cameras that may make these infrastructure somehow an early warning system on the field, not only to protect them from fires, but also to use them in firefighting proactive reactions. For this, the methodology consisted of 4 large phases. I will be explaining each briefly in order to respect the 12-minute set. In terms of building a fire index, we used remote sensing data to build the fire index. As you may see, there are several factors included, including droughts, moisture, flammability data, severity index, moisture codes, ignition components, danger index, and burning indices. In terms of meteorological data, we use temperatures and precipitations as well as land surface temperature. Here is a combination between remote sensing data and observed data. We use topography, data on land use, as well as strategic infrastructures, such as proximity to firefighting stations or to water reserves or water tanks. Here is some maps to show you rapidly. As you may see, the area has very low precipitations in contrast to very high temperatures, making it very fire prone. It has very high difficulty of controlling fires, as can be seen from the burning index. The network is coinciding in the high risk zones. In terms of topography, we have a low topography, but with low slopes, so fires can spread on a plain if you wish. It's a plain terrain, the fires can spread rapidly there. In terms of urban infrastructure presence, as all coastal areas of the world, we have a large aggregation of urban cover there, including roads, buildings, and other urban infrastructure. Past fires, the position of past fires with respect to the pylon network revealed that they are in a high-risk zone, and most surrounding cover is a forest actually. All these ingredients, if you wish, all these factors combined, they go to show one thing, that this network is in a very high fire risk zone, hence the need for an intervention and for proactive planning. For predicting fire hazard modeling, we combined all the layers that I mentioned before, the remote sensing indices, as well as the field observed data. And we used the multiple regression linear modeling to predict the probability of occurrence of these fires. The model predicted more or less well the values with an R-square of 0.77. Well, the coefficient of determination also was satisfactory, and the following map was obtained. As you may see, the probability of occurrence of these fires is mainly concentrated in areas of 75% and higher, meaning that these infrastructure are at high risks of fire. This is a 3D representation of the study area, where you may see also how there's different risks, fire risks or probability of occurrence actually that are there in terms of hazards. As a second step, we had to analyze territorial vulnerability and determine the level of the pylons to then prospect how we can use the thermal cameras. So for vulnerability, we had two approaches, two questions to answer. What burns most, and what is most important for the continuity of life on this territory? From what burns most, we derived vulnerability. From what is most important in terms of infrastructure, we derived strategic potential. Then we had to validate all what we did with firefighters from Corsica, with infrastructure operators, local representative, as well as the local citizens, because they are the most affected. In terms of vulnerability, we saw that we divided it into two, the equipment vulnerability and environmental vulnerability. As you may see, environmental vulnerability is higher. And in terms of equipment vulnerability, the most vulnerable equipment were seen to be industrial or commercial areas. In terms of environmental vulnerability, natural areas were most affected. As we said, most cover there is forest. So in order to establish the global vulnerability, we had, we took several factors that may affect vulnerability. For instance, soil moisture, slope, the proximity to water supply, the proximity to firefighting stations. So each positive value decreased vulnerability, while each negative value increased vulnerability. The global strategic potential, once we did that, we found that it's by using the previously mentioned facts, we saw these changes. And the equipments are actually at higher risks. The residential areas are at risk in terms of strategic potential, and agricultural areas as well as protected natural areas are under high risks. The vulnerability maps were presented from 0.1 to 1. It's a simplified legend with values closer to 1, showing increasing vulnerability. So as you may see, the environmental vulnerability is mostly red, hence a high environmentally vulnerable area. Combining the two factors, we obtained the total vulnerability map, the global vulnerability map. As you may see, there's a gradient of vulnerability there. Again, these maps show them separately, but this time with respect to critical infrastructure, with respect to the distance from critical infrastructure, such as water tanks or the strategic firefighting poles or police intervention zones. Ultimately, we used as we said, having seen the vulnerability as well as the probability of occurrence, we studied the strategic placement of cameras. We have a network of 260 pylons. The cameras are to be placed at 25 meters of height, which correspond to the height of the poles, with a field of view of around 10 kilometers. So we had to analyze them based on elevation. If we put a camera on each pole, that's what we would have seen. However, this is not possible because the cameras are very costly, hence the need for strategic choice, strategic poles. So the options were either we place the cameras according to the high hazard zones. That way we would place them only on 6 pylons and we would see the following. Or we could place them with respect to strategic potential, hence their proximity to strategic infrastructure. Then we would have 3 pylons and we would have this representation, a field of view. Or we could place them according to highest area of vulnerability and then only on 1 pole and have this very restricted field of view. So we decided to combine them based on hazard, to combine this observation based on hazard, based on strategic potential, and based on vulnerability, which allowed us to choose 10 strategic pylons, which when mounted with the thermal cameras would give this view of the terrain. In terms of 3D representation, here's what we obtained. And in case you have further questions or would like further clarifications, please do not hesitate to contact us or for any inquiries. Thank you.
Thank you.
Thank you very much, Mario. Questions for Mario, please? No, we are in a hurry. We are quite late. Any questions?
Just one regarding the feasibility of installing all these pylons in terms of cost and efficiency. Do you have some suggestions? What is the limit of what you can implement or what you can address?
I'm sorry, I didn't hear a lot. What was actually the question?
What are kind of limitations do you foresee or do you already see regarding the installation and the implementation of those pylons in different areas?
The cameras are still not installed yet. It's undergoing, but we had to do this field of view because to show which pylons were more strategic, the most strategic to have a global overview of the area. But as per my knowledge, these are not installed yet. They are still awaiting installation.
Okay.
Okay, thank you. Thank you, Mario. Thank you very much. I hope that everybody is okay at home, okay, with the pandemic. We go for the next speaker is Rebecca Leis from Valencia in Spain, and she's going to talk about greenhouse emissions, risk management in forest fires. Okay, go ahead, Rebecca.
Okay. Bueno.
Te escuchamos, sigue.
Sí, ¿me escucháis ya? Are
Sí.
you see me?
We go ahead. Yeah, go ahead. It's perfect.
Right.
Excellent.
So, okay, now I think you can hear me now. I'm going to share my screen. Okay. Can you see my screen?
Now.
Now, but you can see it as presentation?
Yes. You
Okay, perfect.
Just keep going.
Okay, thank you. Thank you so much first of all, thank you so much for the organization and to be able to be here online. I would prefer being there in person, but well, next time I hope it. So, I think you can hear my presentation in now. Okay. So I am Rebecca Leis. I'm from the Association of Forest Municipalities of the Comunitat Valenciana. We are the coordinator of the REMAS project. I'm the general and I am the general coordinator. So here you have my email if you want to have more information about the project, because we have oriented this presentation as a more general one in order to introduce you the REMAS project. But if you have deeply specific questions about methodology and so on, you can ask us via now or via email, or we can schedule a meeting. So I am going to start the presentation with a video, a short video that explains very well the transnational cooperation, the context of the project, and the objective. So, and after I will introduce you our working groups and also the product in which we are working on, and a brief conclusion. So for the video, I am just a minute because I need to close this. I know I need to close to stop sharing this one. So I don't know. It is detener. Oh, now okay. Maybe it is my connection, but it goes very. It's not quick. Okay, so aquí. I think you can see it. So I am going to the voice are the voice in Spanish, but we have subtitles. So I hope that you can read them. If not, let me know, please.
I was ready to translate the Spanish, yeah, but we cannot hear.
Rebecca, here we can see very small subtitles because we had some
Hi.
issues with the online presentation, so it's fine. Online attendees can see and read well, but it would be great if you could summarize along the video something.
Oh, okay, sorry. Okay.
You can continue the
I am going to read the subtitles, so in this case you can hear better.
Yes. Well,
Okay.
okay, actually, so please just explain something along the video, please.
Okay. So, okay. So here are the experimental area in the La Concordia station in Valencia, which is La Concordia, and in which we have made experimental fires. And we are studying the carbon in a different period. And well, like here we are saying that in the project we are working on the different profiles in public administration, association, and so on in order to work together in the management of the forest in the emission risk in emission management. So I'm very I'm sorry for that because I thought that you could read it well. So this video is not already public, but we will place it in our website and social network, so you can go there and see it when we upload it. Okay. So as you can see, we are working on different areas in France. Sorry, it doesn't work very well. Okay, here. We are working in different areas in France, Portugal, and Spain, and also we are associated partners in Andorra.
Sorry, are you supposed to share your presentation or something?
Yes, I'm doing that, but
Please
it is
read
very
again.
quick. Sorry. Okay. Maybe it's my connection. I don't know.
Now it's coming. So please enlarge it.
Yes, I am going to do that.
Thank you.
Okay, perfect. Now you can see it well. Well,
online attendees will be.
No.
So please just explain with words.
Okay.
I cannot see it very well.
So here, just I wanted to include our partnership. We are 8 entities and 9 associated partners. And we started the project in 2019, at the end of 2019, and it will finish this year. So this year we are working on a final conclusion and so on to publish our results. So here is a summary of the experimental of the study areas in REMAS, and also that we are working on the pilot areas affected by large forest fire. Here we have included the areas that you have seen in the video, which are forest fire from 2012, 2015, and 2004. So,
do you have any results from the project?
Yes, we have, but not here. When we send this for this presentation, we are not going to show. I am going to show some specific results, but it's not focused this presentation on results, just to submit, just to introduce the project, because the results are going to be public within this year. So this was not oriented as a specific on a specific product, on a specific item. So I'm sorry.
Okay. Then any questions?
No, but I haven't finished. So I want to say here, for example, for the working groups and product, here we are going to obtain a methodology. We are working on we have worked on a methodology for the greenhouse gas emission risk, also in technical and scientific publication. After I will show you some ones. An action protocol to minimize the greenhouse gas emissions. Also, the main project is the International Action Plan for the Inclusion of Emission Risk in the Planning and Sustainable Forest Management, at least in the participating regions. Also, we will offer in the last quarter of the year training action in which we are going to compile all the REMAS results in video. Now we have launched one for example, in Spain, we have launched one but it is closed just for public regional, for the regional administration, but the other one will be public to all people. Also, we have established a platform for the emission risk management. Now we are working on improve it, but I will show you after. And a memorandum of understanding for include the emission risk in the planning instruments and sustainable forest management. So here, for example, you can see, well, maybe there the people who is in person cannot see very well, but here is a result of the total organic carbon in Selva, which is the study area in Valencia. And also here we have with remote sensing, we have calculated the carbon stock in vegetation. Also in Selva Forest District in 2020 and 2006. So we are obtaining different cartography. Also, we are working on a cartographic viewer that you will access this year, at the end of this year. So here is a summary of our greenhouse gas emission risk model. This model is a tool for statistical and technical planning. The model is composed mainly by three factors: the spatial and temporal risk of a high-intensity fire, the amount of carbon that the ecosystem stores in vegetation and soil, and the vulnerability of this ecosystem to fire. So here is one of the results that we obtained in June about the emission risk of Pinus of the ecosystem of Pinus alepensis in the Selva Forest District for 2012.
Can you change the slides?
I'm thinking. Okay, here. Yes. I didn't understand your request.
We are watching all the time the same slide.
Now I'm showing you the emission risk, the emission risk model, and now I'm showing you the emission risk map.
No.
No. So what are you saying? What are you seeing at this moment?
Partnership.
Partnership. Oh my God. Okay.
Now yes. Now you're moving.
So I show you a lot of things. Well, I show you.
The problem is
okay, thank you for saying to me. Because
the problem is that we are running out of time. We still have you have more than 20 minutes already now, and we are out of time, and they still have a presentation.
Okay, so sorry. So okay, just to show you the different. We have working on different scientific articles. Also, you can check our YouTube with different content of REMAS, and well, that's all. I want to, if this possible, I will want to show you more things about the groups of stakeholders that we have created, but well, you can see it in our website.
The problem is that we have only 15 minutes per participant, and we are now running 21 minutes out of time.
Okay,
So we
maybe.
need to go to the last speaker. Okay.
Well, I have here my, well, I was also monitoring, and maybe with the, well, it's okay.
Rebecca, the idea is that all of you sent in advance your presentation, so.
Yes, I sent it.
It could be possible, I mean, if you don't mind, just all of you send the presentations to the organizing committee, to Saskia in particular, and I think that they will be available on the website maybe, so.
It's because we need to go for the next one, which is Victor Mironiuk.
I sent it this morning to Marta.
To me?
Yes.
It's,
yeah, you have to send it before Sunday, but we cannot check now the emails during the session.
Okay. We go for the next speaker. Some people is abandon the room now. Victor Mironiuk, are you? Unmute him.
Please.
Okay. Well done. Can you talk, Victor?
Hi, everyone.
Okay, excellent. Go ahead.
Okay, I will try to share my screen. Can you see my screen now?
Yes, yes. Go ahead.
And it's scrolling.
Yeah, it's going well. There,
okay,
go,
okay.
Go ahead, and thank you.
So, hello, everyone. I'm glad to be here even remotely. So in this presentation, I would like to share with you some results of our study about mapping fuels within Chernobyl exclusion zone and how all this can be integrated in wildfire simulation. Wildfires within areas that were contaminated after nuclear plant accident in 80s is a major problem in this region because of resuspension of radionuclides that can travel long distances towards populated areas, towards Europe, and it also a big problem to firefighters. So the information about vegetation structure is important to understand potential wildfire risk within these areas and improve fire management. For example, several years ago, we firstly assessed the wildfire risks within this region, and we identified hotspots, and we also tested different field treatment scenarios and offered them to wildfire manager. Unfortunately, large wildfires that occur within this area changes landscapes, and for example, during just 2015 and 2020, about 1/4 of the Chernobyl exclusion zone were burned. So it meant that the information we used previously in this wildfire simulation needs to be updated. On another hand, such high frequency of wildfires mean that they will probably happen in the future if there is no improvement in fire management. So we need to have some cost-effective system that can be used to update fuel layers that used in wildfire simulation. So the main objective of this study that I am presenting is to develop a cost-effective approach to map key characteristics of the landscape, specifically with focus on canopy fuels. So in this study, we utilized a long time series of Landsat data, nearly for the last 3 decades. We used interpretation of sample points to identify key land cover classes. As well, we used recently launched JADAI LiDAR data to map canopy fuels. Specifically in this study, we focused on mapping canopy base height, which is very important to understand the transition of ground fires into chrome fires. All this was done in Google Earth Engine Cloud platform that seamlessly integrated both our approaches. So for mapping fuel types, we used random forest classification of which is realized in a continuous change detection and classification approach. That is very popular time series analysis approach. And for mapping canopy height metrics, we used one of the nearest neighbors approaches named as gradient nearest neighbors, because it allows predicting multivariance response at once. So in this case, we can treat each sample point like cohesive unit, like stand, with specific distribution of canopy height characteristics within this sample point. So we used in our classification a scheme that was proposed in FireView Risk project, slightly adjusted to our study area. So the key advantage of using a continuous change classification approach is that we can utilize one classification model to get land cover characteristic and link these few land cover types with corresponding fuel layers to get updated information about fuel types, their distribution within that area. On this slide, you can see that besides classification, just spectral data, we can classify temporal segments of satellite imagery, so we can get continuously updated maps for any given date we want within a specific time range for which we got satellite imagery. In terms of mapping specific fuel types, it allowed to better discriminate some very similar land cover like grassy vegetation, because they have very different temporal profiles in different spectral bands. On this map, for example, you can see the classification which can be performed for any date within our time range. And it's very important that this classification model depicted very well croplands, which appeared here in orange. It means that we can use various fuel type models for different seasons, because crop times in this area burnt in April, but they don't burn, for example, in June. But this forest non-forest masks, which you can see in green, we used to combine this information with JADAI data. So we analyzed two products of the JADAI data to understand how relative height metrics can be combined with full waveform data to get approximate prediction of canopy base height. So we analyzed various various stands that had different species composition, age, density, and realized that cumulative energy return is the major increase in cumulative area return is connected with canopy base height, which you can see on this slide. So we decided to use 5% beans of energy return to find the larger increase in this distribution, and we use this at pixel level to map canopy base height. So finally, we created an approach that is fully integrated in Google Earth Engine that can be used to update fuel type maps. Then we can use forest, non-forest mask to extract training data from GEDI dataset. And then we can train our imputation model to predict canopy height, which we decided to use like 95 percentile of relative height metrics. And then at each pixel level, we can predict canopy base height. Of course, all this approach is this approach needs to be tested with reference data, which of course we will be doing in the future. But in general, that is very important to have this tool in areas that are contaminated by radionuclides. And recently, this area is contaminated by unexploded bombs. So as a conclusion, we think that integration mapping approach within cloud Google Earth Engine is a very good solution to get updated distribution of fuels within such remote and restricted area like Chernobyl exclusion zone, and use this information in wildfire simulation. So thank you for your attention. That is not finished work. It will be continued, and we will try to improve this model. Thank you all for the attention.
Thank you, Victor.
Okay, questions to Victor? We are running out of time. It's because here they can see me. If no questions, we are very exhausted. It has been a long day, and all the audience that are online. Then I think we must conclude here. We finish the presentation, and we will see tomorrow. Okay. For all that you are interested in forest fires, just announce you that next year there will be a congress in Granada that we will organize in collaboration with University of Granada, with Jesus Rodrigo. Will be in July, in 1 year time. And the Congress is the second edition of the Fire in the Air Systems. Okay. Nature and Humans is the title. Then we want to highlight this. Okay, then you will receive information from us. Don't worry about that. Okay, but you can think about to visit Granada next year. Okay. Thank you very much.
Thank you, and sorry for the technical issues, Rebecca. We will try to circulate your presentation. Okay.
Okay. Thank you.
Thank you.
Close everything, Malika. Thank